Hello and welcome to another Solana tutorial. This is episode 1 of my series on Solana program security, where we're gonna go through some common errors that can happen when you write smart contracts on Solana, aka programs. So it's not focused on the users, what they need to do to stay safe, but developers, what they need to take care of when writing programs in order for the programs to be secure. Got it? Cool. That's what we do in this series. It's gonna be shorter videos. I mean, short for my standards, hopefully. Every episode will have a look at one specific vulnerability, and we'll just see where it goes from there. I might have some hacking challenges for you. Unfortunately, my game of death died. I just didn't find funding for it and it was too much work to keep it up. So that kind of just disappeared. But maybe with this series we can bring the discussion about Solana security back into your mind. Okay, let's get started. What are we going to talk about today? I think I want to talk about bumps. So hold on. Whee! Let's open a browser real quick and go to soldev app/course. Because James, in his course, here in the last module, is talking about Solana program security. Some of my topics will be based on that, but we're not going to go through it like one by one. We have talked about signer and owner checks in previous videos because that's just so important. And today, bumps it canonicalization. What a word. I think that's what I want to be talking about today. Let's just start with that because there's no reason not to. Yeah, so I can recommend that you go through those lessons by yourself as well. This course always a great resource. And then also, while we're talking about security and I plug resources, security.superteam.fun. Superteam has released like a security CTF, which if you like the game of death, you might like this. So here they have some background like on the biggest Solana hacks that happened, where they explain what was the exploit and they go into more detail. And then there's this CTF, a capture the flag, with different challenges for you to try out like this. Yeah. So that could be quite interesting for you. I'm not going to go through this today. I'm just going to theoretically talk a little bit about bump seed canonicalization. And to do that, I'm going to write myself an anchor program. How about SEC for secure? Because everybody loves the SEC, obviously. Everybody in that space absolutely adores them. So what is our program going to do? Or like the idea, let's pretend it would like distribute some free stuff, but only one per user, right? So every user can claim one whatever NFT or whatnot. And so I'd write the distribute instruction with distribute accounts. And the accounts we need is first of all a user who is claiming. And then we're gonna create an account that stores that this user has claimed, because somehow we need to put that in the state. So we kind of need an account. So let's do an account, which gotta be mutable. There we go. We finally found the SEC, whatever it's called. What are we going to store in this account? Well, really, we don't need to store anything. The fact that the account exists is enough for me to know that this user has claimed. I mean, I could store claimee in here, but I'm not going to use that anyway. So whatever. And the way I can guarantee that if this claim account exists, my user has already claimed, is by every user just having one claimed account address. How do we do that? Well, with a PDA. So we just ensure that this account has seeds that just depend on the user. And maybe some static string claimed, whatever, something like that. So the user public key is used here in the derivation of the PDA. Therefore, each user will only have this one claimed account. Then copy our program ID here and here. Do I want to go to DevNet? If I go DevNet, I need Sol. Let's see if we can build that, and then Anchor will tell me, no, we can't. Oh, because I didn't save it, that's why, okay. bump must be provided with seeds. And some other stuff that I messed up. For instance, that I didn't declare this as an account. Okay, so we can't use seeds if we don't have a bump. So we just provide the bump. And as we've learned in one of my previous lessons, if we provide the bump directly here, then that's more efficient. So that's what we're gonna do. And since we just create this account here and I haven't stored it anywhere yet, later I will store it in here. But here when we create it, I don't have it yet, so I'll just provide it as an instruction data, the bump. And then essentially all we do is we create the account. If we can't create the account with the system program, then it probably was already created, and then we say fail, you can't do that. And if we can create the account, then we distribute our whatever we want to distribute. And again, I'm lazy. I'm just gonna let Anchor do all the work for me. I say, please init this account, let the user pay, and space, well, we have 8 plus 32 plus 1 is 31. Did I say 8 plus 32 plus 1 is 31? I mean, sometimes I really wonder how my brain does maths. 8 plus 32 is of course 40, so the whole thing is 41. Don't like the bump? Why not? Damn, Anchor, you too smart. Bump target should not be provided with init. Please use bump without a target. Okay, we see Anchor is already too smart. I can't even outsmart Anchor. That's the problem with using Anchor. It's already helping you so much that it's even hard to build programs that are exploitable. Well, then forget what I said. I never said that. We never know. We just know. We're gonna be stupid because we can. So all we gotta do is do a system program, create account. Oh, of course, if we want to call the system program, we better get it as a program. Oh, come on. System program. Although I'm not sure. Let's try it just with create account. Space in Lamperts. 8 plus 32 plus 1 is 41. Owner will be... Well, actually, the owner should be me as the program. Can I just get the ID? Is that my ID? I don't know. We'll see. There's a better function for this. There's a new with signer. Program ID, accounts, create account. A to and from, that kind of makes sense. From is my user, he's paying that to account info. That's my claimed account. That's the one that I want to create. And then the signer seeds, well, here we just need to provide the same seeds as here. Plus, of course, the bump. Oh, I don't need to say this is signer seeds, so that's better. User key as reference, of course, I need to get from accounts. That looks okay now. All right, not so easy, but we'll figure it out. Okay, you want the account info here, that's fine. I also can provide that. Accounts, that's why I passed in the system program. You can have the account info. Okay, and now, how do I get the program ID? Oh, the context has the program ID. I mean, it's so easy. Hold on. You have my program ID, of course. Perfect. So, okay, what it's now complaining about is that I'm not using the result, which is not what we want, because obviously we want, if the create account CPI doesn't work, we want to raise that error. And we'll be like, okay, this account is already created. Move on. And otherwise, only if this does not return the error, we here claim this cool stuff. That's where I would put the actual logic that distributes the whatever. But for our purposes, a message is enough. If we reach that message, then we know, yeah, we managed. There's one more change that I'm gonna do. Don't look too closely. I'm just gonna remove this, that it doesn't check the type. Just because I want to manually initialize it, and otherwise it would already check the account type here, which is not what I want. So it's just gonna, right, I know what I'm doing here. This is safe. Check. I totally know what I'm doing here. Scroll up. Nothing happened. But that's not the, like, that's really just because Anchor is too protective of me. I mean, yes, this leads to not checking if the account is of that type, but we're not using that type anyway, so it doesn't matter. what I'm doing wrong here now, by the way, is it type cosplay? Yeah, to implement the discriminator in Rust. So that's what James understands as type cosplay that you could do here now because I'm using an unchecked account and I don't check what is there. But anyway, I don't have anything written in that account. I don't write to that account. I just create it. If I can create it, then I'm like, yeah, safe. So yeah, that's a different exploit, but in this case, you can't really exploit it because I'm not using that account anyway, in the sense that I read to or write from. No, read from or write to it. Let's quickly start up my local test validator and airdrop myself a ridiculous amount of salt because on the local test validator I can. Nice. And then we're gonna quickly build and we're gonna wait. First we copy the SEC to the key pair and then we deploy. There we go. The secure program is deployed. Let's test it. We create ourselves a new file. Heck. I'm just gonna borrow some code from another time we did something. There we go. So distribute, which just takes the bump. So we gotta derive the bump, of course. So we gotta first derive a PDA. The seeds were claimed and then the user key. So claimed and then user, which in my case is the key pair public key to buffer. Then we have the bump, so we can provide the bump and the accounts, which are the user and the claimed, the PDA, and might as well provide the program ID. And then we get that instruction and then we build a versioned message. Actually, I'm gonna not do it that complicatedly. I'm just gonna RPC this. Cool. Let's see if that works. Is node hack it. This is not a hack. This is the normal using it. Make this even bigger. There we go. We get a signature. So that worked. We confirm this. Then we see that our SEC program is called with the instruction distribute. The system program is invoked. So that is done with success and we can claim this cool stuff. But if we want to now do that again, claim the same thing again, then this should now fail and tell us, hey, the account already exists. There we go. It is telling us the account already exists with a 0x0. Pom pom. Already in use. Nice. So my program works, right? Right? There's nothing that can go wrong, right? Right? Of course. Of course, there is an issue with this implementation. Can you tell? Wait, I'm going to show you the code again. Can you tell me what the problem is? Dear student, my good students, you can totally tell me what the problem is, right? 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 Remember, we want every user to just be able to claim once. But what can a hacker now do to be able to claim twice? They can create a new address. Yes, fair enough. But that's then for us a different use case. If they have a different address, then they're fine again, right? That's not what we protect against. That might be a logical failure then from our side, right? And those are also errors that we need to take into consideration. Even if the program works fine, maybe our design is just bad. I think that was the case with the Mango hack, I think. With the design, that the program worked as intended, just that their design space was like not well thought out. But yeah, in our case, we might in some other way limit the users here. Maybe the user is limited to an NFT holder or whatever. Or it's an actual NFT and then you take the NFT here. So like I would do with my hackers, that every hacker has like one claimed account, right? And they are limited. You can't just create a new address. But that's a different kind of a hack. With the constraints that one user wants to claim several times, what can they do? What can they do now? What's the obvious thing that if you're a hacker, you would now do? I think you all get it. If you don't, raise your hand and I'll come to you. Am I a teacher? I won't come to you. This is way too far. But I'm gonna tell you all anyway now. So obviously, to be able to claim again, we just need a different address here such that this thing still works and we can get to the claim again. How do we get a different address with the same user? Well, our PDA depends on those seeds, but the bump is also part of our seeds. It's the last byte. So we just need to provide a different bump. Now, of course, we can't provide any bump because we need to provide a valid bump. If it's any bump, then the signing will fail here and it's not gonna work. I will also show you that. But if it's a valid bump, then we can claim again. In fact, let's log it. What was our bump? So our bump was 255. Okay, the first bump already worked. We can, of course, instead of finding the program address, we can just create program address, which then just gives me the PDA and not the bump anymore. But I can provide the bump here as another byte. And for instance, I could go with the next available one, 254. I'm gonna make it a uint8 array because then I can pump it in directly. Actually, other way around. I'm gonna make the bump 254, and then I'm gonna put the bump in here. And then I'm gonna put that right here because that saves me a line. Okay, so we put the bump here as well. Actually, let's start with 255 just to see that that's the same thing now. There we go. We're again using bump 255 and we're again getting the 0x0. But what we can do now is using bump 254. Now it can happen that the create program address will already give me an error. We have about a 50% chance that it succeeds. Looks good. So we're now sending the transaction with bump 254. So that seems to also work. Seems to also be a valid bump. There we go. And we hacked our program. With the same user, we were able to claim once again because we did not set the bump to the canonical bump, but we just take the bump from instruction data. That's why it's important to always use the canonical bump. Otherwise, several PDAs might be valid for this. So this can have consequences in many shapes and sizes. In our case, we were able to create several of those claimed accounts.
So how do you fix it? Well, easy, by not providing a bump here and just saying take the canonical bump. Then we're sure that it's always the highest possible value for that bump, and just this highest value is allowed, no other one.
And then if we do that, we could also let Anchor init this account directly. I had to do it manually because Anchor didn't allow init with a bump that is provided from someone else because security. It's not intended to do stupid stuff like that. I just did it to show you what can go wrong if you do that. To wrap it up, I do want to still show you what happens if we take a bump that is not valid. Maybe the 253 will not be valid. There we go. There we get this error when we call the create program address sync because the address must fall off the curve, which this one didn't. This bump is just not a valid one. If we still force it in there, actually then the PDA doesn't work. And I can't create it by keeping it on the curve. I would need to go one step further, derive it myself. Actually, speaking of deriving it myself, I do have seeds on, so how about I just don't provide this? So I don't provide that. You can derive it yourself, lol. And I'm still gonna use that bump. What would happen then? Oh wow, we even get to the simulation. Nice. But then the Anchor program tells me, Anchor error, caused by account claimed, error code, constraint seeds. A seeds constraint was violated because it doesn't derive a valid PDA. Nice. But we even managed to get so far as to simulate it. Nice. Yeah, so essentially you could now loop through those, and whenever you get a valid PDA, you could call again and claim. So you can get up to 255. Not really, because some are not valid. So approximately maybe half. Each user could claim around 120 times. which is not what we intended. So that is definitely an issue. I mean, I don't know what we are distributing here and how valuable it actually is. I mean, getting this message, you know, not the worst thing in the world if several people get that message, right? But if that was something like, if that would actually distribute, I don't know, $100 each, then that would be bad. Also, it would already be bad that anybody can just sign up for that we don't like check that the user has to be some specific account or whatever. But anyway, that's a different topic. Okay, cool. I hope, toko boom, that you learned something. This was a quick excursion to bump seed canonicalization. The Solana dev course does go a little bit more into depth actually, or has a look at it from like different angles. They did it a bit differently. They derived the program address in here. You can see a different aspect of the same error, how it manifests there. So yeah, go check that out if you want. And otherwise, I shall see you in the next video in this series, or in any other video that I make, because I make a lot of videos. If you're a Solana dev, definitely go learn about Solana program security. It's so important that you know about all those concepts, such that you don't make those mistakes, because hacks are bad. They're bad for the ecosystem as a whole, because like the more hacks there are, the less people trust. And for the space to mature, people need to trust the apps. So having open source code is good, testing a lot is good, and learning about vulnerabilities is great. And I hope I can do my part by teaching you about those. So I will see you in the next video. Make sure to check out those and like and subscribe, and then I will see you next time. Keep on learning.